I love this. One mark here. Okay. So let's see. Net force of magnitude F acts on a body. Here's some force, right? Define the impulse of the force, right? Well, impulse, I is equal to force times time, right? They've already defined the force as being the force that acts on the body, right? And then what you need to do is state that the time is the time which the force acts on the body, right? So impulse is force times time. T is the time that the force acts on the body. Okay. Let's see. Let's do B. We're going to do A and B here. All right. Let's see. It hits this thing and strikes the vertical wall, rebounds horizontally, right? Which is a neat trick. Anyway, there it is, right? So due to the collision, 20% of the ball's initial kinetic energy is dissipated. Show that the ball rebounds from the wall with a speed of 1.97 meters per second. Okay, so here's what you're going to do. You're going to figure out the kinetic energy before it hits the wall, right? So figure out this kinetic energy. So EK is 1/2 mv squared, right? So go 1/2. What's our mass? 0.0750. Notice we have 3 sig figs here, right? 2.20 squared, right? So figure that out. That's a number, okay? Multiply by 0.80, right? And that will dissipate 20%, right? This is 20% is gone, right? And that will give you another number, right? Okay, that's another number, right? So okay, and then just feed that back into this formula here. That number here is going to equal 1/2 0.075 times v squared, right? So we've done problems like this. In fact, these were one of the problems that were on an assessment, right? So figure out the initial kinetic energy, right? Multiply by 0.8, and then you will have lost 20% of the ball's initial kinetic energy, right? And then feed that back in there, and you'll get a velocity, okay? When I did it, I got 1.9677 or something like that, okay? So there we go. That's not too bad. It seems like a lot of steps for 2 marks, but there it is, right? Then they say, show that the impulse given to the ball by the wall is 0.313 newton seconds, right? Well, remember that impulse, it's not just force times time, right? Okay. Okay. Impulse is also equal to change in momentum, right? So impulse is equal to the change in momentum. Okay, so the change in momentum is going to be, let's see, it's going this way, and then after it leaves the wall, it's going to be going this way at 1.97 meters per second, right? So what you're going to do is you're going to go mass, change in momentum is mass times change in velocity. Right, now remember, the change in velocity is a big number, right? The mass is just the 0.075, right? So plug that in there, right? But the change in velocity is from positive 2.2 or negative 2.2. I think they just want the absolute value of it. So 2.2, it's going the other way at 1.97, right? So you ultimately end up adding those two values together, right? The 1.97 and the 2.2 to get the change in velocity, right? And then you'll get 0.313 newton seconds.